Okay, so what I've done here is, since this is a dynamics, we have the sum of the moments is equal to I alpha. So if there's no rotation, then I alpha is equal to 0. So I alpha is only relevant if this breaks. So if we're assuming that this doesn't break, then we can just set I alpha equal to 0. So if the question is asking does it break, then we're saying is I alpha equal to 0. If we're saying that it does break, then we know that I alpha is greater than 0. But if it's asking does it break, then we need I alpha. If it's telling us that it doesn't break, then we know that I alpha is equal to 0. So what I did is I summed the moments, and I put this M2 as negative so that it would be going in the opposite direction as these other two. But really it should be positive, because if we just put it in as it's drawn, then it should work out. So if we just write everything as it's drawn and we say this is positive, and really what you should do is you should put an arrow and indicate which direction is positive. Okay, so what we have here is we're going to solve for this, and then what we get is we have M2 equals a certain value, and this value that M2 equals will tell us how much resistive force there needs to be, what is the resistive moment if this object doesn't fall off or break, right? So this resistance is caused by this force in the x, right? So but this force in the x is over an area, but we don't need to concern ourselves with that at the moment.